I'm going to work through this problem in real time, explaining my reasoning like I would in an interview, including mistakes and course corrections. If I hit a wall after a solid attempt, I might check a solution, then break it down and code it myself. The classic two-sum problem. Let's see if I remember it correctly. Cool, so we can't use the same element twice, and there's only one solution. There will be only one solution if available. Okay, so the general gist is we go through these numbers, and if two values within this vector or array add up to the target, then we have a solution, and then we output the 0th index solution. Yeah, it looks like a 0 index. This is 0 and 1. This is 1 and 2. So 2 and 4. Yeah, and we return the indices of them, and we'll have exactly a 1x2 vector, or two value vector, as you can see, being the indices. And it looks like we'll always have a solution, at least from my understanding. There's only one valid answer that exists, and it will exist. But we can always return nothing if that's the case. Whatever would be the use case for a function like this, which I'm not too sure really. Okay, so I think I have a good grasp of what I'm supposed to be outputting, and then like the values I'll be given. So I'm thinking of possible solutions right now. Currently, I don't think I need to sort any values. Reason being is because I'm going to use our handy dandy hash map. So for the data structure hash map, which we'll be calling which would be the key will be the remainder, and the index, or the value would be the the value would be the initial index. So for example, we'll do for this first one, 9 minus 2 would be 7, excuse me for blanking right there, and then the initial index will be 0. So this will be the what created that 7 in a sense, being this 9 minus 2, and it's the index that created it was the 0th index. And the reason why I would like this this data structure format is because I would like to find it. Use the find function in hashmap. Yeah, use find to check if we have the remainder needed to get to target, right? And if we find it, then then we found our solution with the previous index and our current index, in a sense, our initial index and current index. Return that. If not, continue. All right, just continue. If not, oh yeah, if not, then add to the hash map. And it's been a while since I've used some functions in hash map, so I'm gonna be looking at some methods for that. But that should be the general format. And this is a O of n space and time complexity. Reason being, because this hash map could be as big as the vector input for space complexity, and then at maximum, since we see each value once at maximum, because we only have one for loop, then that's O of n time complexity. This seems like the best solution that I can think of at the moment. I don't see anything better than that. I don't think sorting is very beneficial in any way. It would be making this slower. So I'm gonna try to implement this the best I can, at least. Let's see. So looks like both of these will be integers, and I don't really know. I don't know. Remainder map, I guess. I'm not really sure what the value or the map would be called currently. I might think of a different variable name, but it doesn't really matter right now. I is less than nums size. The reason why I'm opting in for this type of for loop, the classical for loop, integer based for loop, is we need the index, or index based for loop. So let's see. This is where I'm going to need to look up the methods and CPV reference. So we have insert, which is fine. Don't really need that right now. So I guess we can still use contains. Interesting. I usually use find, and it gives me the iterator, and I don't do the end. But I like contains better. I'm not really sure if there's like a I still think that that's a O of 1 operation still. I think they're both O of 1 operations. I couldn't imagine it not being that. Yeah, it should be O of 1. Everything lookup for hash map should be O of 1. So if so we should do the int remainder is equal to target minus nums I. Okay, cool. Okay, if remainder map dot contains, if we find the current value, that means we found the remainder needed to get to target, to add up to target. So if this is true, then we can return I and remainder map nums I, which is the index for that. And then else, we do remainder map of remainder is equal to I. Yeah. And this should work even with duplicate values, because it should find the number if that's the remainder. And just go opt out for this part. Yeah. Let's see, I think. And if all else fails, then we do, I don't know, 0, 0 or something. It shouldn't fail. But whatever reason it does that, then I guess we'll fail. All right, so let's go through a dry run. I guess we call it rem map. Okay, and then we're gonna go iterate through each one. So we don't find any the num3 in rem map because there isn't one. So we add it to the list, and it'll be 3, 0. And if we get to 2, the remainder should be 4, since 6 minus 2 is that. And it should be index 1, right? And then 4, we see that it contains 4 in here. We found the key 4. So we return index 2. And then the remainder map of 4, which it happens to be the value of 1. So it's 2, 1. And I could switch it, but it says return the answer in any order. So I'm just gonna do it like that. Not a huge deal. And let's go through the edge case of even this guy, right? When we have duplicate values. Gets a little scary with duplicates, man. It's real scary. Alright, whatever. So this one, we have the same 3, 0. And then once we get to here, same thing, we see that it contains it, so we return 1, and then whatever this value is, which is 0, so it's 1, 0. And that should be the solution. Hopefully I didn't mess up any syntactical errors. So let's see if that works out. At least past the base cases. So let's see if we, let's see if it passes all the test cases. And it does. And it should be faster than that, I assume, but this is a O-Van space and time complexity, so that's pretty fast. I don't think there's any faster solution than that, and there might be some small optimizations with space, but besides that, it should be the same time complexity and whatnot. Yep. Anyway, that was a pretty fun question. It's been a while since I've done that.